All right, yesterday we talked about a bunch of different types of sequences, and we were writing formulas for how to generate those sequences. We did that like at the end of your notes yesterday. There are some sequences that can't be defined by just saying, oh, it's 2n plus 1 or something like that. It's not quite so simple. A great example of this is the Fibonacci sequence. So sometimes sequences have to be defined recursively. So that is one in which the term, any term in it, is determined by the numbers before it. Okay, in order to write a recursive sequence, you need to give what the first term is, or maybe the first and second term, and then give a rule how you get the next ones. So the important thing to remember here is, remember you start with A1, and then A2, and A3, those are your first three terms, or you might start at 0. And then somewhere in this sequence, you have AK. That's the kth term. The term that comes after this is AK plus 1. The term that comes before this is AK minus 1. Okay? The term before that would be AK minus 2. And the term after AK plus 1 would be AK plus 2. Okay, so if you were just talking about just some random number within the sequence, a sub k, the number after it, the term after it is AK plus 1, the one before it is AK minus 1. So we'll refer back to that. So we want to kind of do it the same pattern we did yesterday, is we're going to be given a formula, and we want to write the first 5 terms. So here's how this one works. It says A1 is 6, so they are telling us the first term of this sequence is 6. To find AK plus 1, so to find any term in the sequence, you take A sub k and add 1 to it. Well, we need to think, where is AK in comparison to AK plus 1? This is the term before. So what this rule is saying, I guess we need an E on the, is to find a term, AK plus 1, you take the term before it and you add 1. Okay? So to find the second term, we're going to take the term before it and add 1. And to find this term, we're going to take the term before it and add 1. And to find this term, take the one before it, add 1, and add 1, and so on and so forth. Okay? So this is a recursive sequence. Let's try another one. All right, so this is telling us that A1, the first term, is 3. We want to write the first 5 terms. We'll keep going. So what this is telling us is if we want to find A sub k, we take 2 A sub k minus 1 plus 1. Well, we need to think about how those are related. If we're looking for AK minus 1 is the term before. Now, notice this one's written a little bit differently than the last one. The last one was AK plus 1 and AK. We can do the same thing with AK and AK minus 1. So what this rule is saying is if you want to find any term in the sequence, you take 2 times the term before it and add 1. So to find this term, we're going to take 2 times the number before it and add 1. So that gives us 7. To find this term, we're going to take 2 times the number before it and add 1. To find the next term, we're going to take 2 times the number before it and add 1. And to find the next term, you take 2 times the number before it and add 1. Oh, I guess we only needed the first 5 terms. Good enough. And so on and so forth. All right, one more of these. We want to write the first 6 terms of this sequence. So we need 6. Oh, they are telling us that we are going to start with 1. Okay, notice this sequence starts with a sub 0 instead of a sub 1. No big deal. The next term is 1, and we want to find 6. So 1, that's 3, 4, 5, 6. Okay. Okay, so now we have to look at our rule. To find any term, if we're trying to find AK, we need to take AK minus 2 plus AK minus 1. So we need to think about where these are. From AK minus 2 is 2 terms back. And from AK minus 1 is 1 term back. So what this rule is saying is if you want to find a given term, you take the number 2 before it and the number 1 before it, and you add those together. So let's actually do this. If we want to find this term, we take the number that's 2 back, the number that's right before it, we add those together. 1 plus 1 gives us 2. To find this term, we have to take the number 2 before and 1 before and add those together. To find this number, we need to take the number 2 before and 1 before. And to find this term, we need the number 2 before and 1 before. Okay. So this is our sequence. 1, 1, 2, 3, 5, 8. Hopefully you recognize this. This is, in fact, the Fibonacci sequence. The Fibonacci sequence cannot be defined in any other way except recursively. If you want to know the 200th term of the Fibonacci sequence, you need to know the 199th and the 198th term. So you would have to list them all out. So it's kind of a downside of recursive formulas, but sometimes they're the only ways to go.